Changes around us. Introduction. Every day we see different types of changes around us, like day turning into night, season changing, melting of ice into water, cooking of food, and so on. All changes are not of the same type. We get back to the original substance in some and can't get them back in others. The stories in which the good fairy granted wishes to the people and they were magically able to change everything around them. Their huts became palaces, their torn clothes turned to silken robes, and their brass utensils at home changed into utensils of silver and gold. Such changes are brought only by fairies in stories, but in reality, also there are numerous changes taking place around us that we often ignore or take for granted. Often, sudden changes are noticed and very slow changes escape notice. For example, when you switch on the ceiling fan in your class or home, it starts moving that you notice immediately. But the wearing off of the paint in your classroom is so slow or gradual that you do not notice it. In our surrounding, so many things keep changing around you. The sun's position in the sky changes from east to west during the day. Flowers bloom and then wither off. Your clothes become small. In fact, you grow taller and stronger. You need a haircut and nail clipping because your hair and nails grow. Different crops in different seasons grow and mature. There are so many changes surrounding us. Are there any similarities or major differences between the changes around us? You have already seen that some changes are fast, others are slow. Fast or sudden changes we observe at once, but slow changes are mostly not noticed by us. Take a rubber band and put it around your pen. Now hold the pen and straight in tightly with one hand and with the other pull the rubber band. You will observe that the length of the rubber band changes or increases. If you slowly bring your hand back, the rubber band comes back to its original size. You can see the same change in the size of a balloon. When you blow air in the balloon, it increases in size, and when air is taken out, it comes back to its normal size. Take a thick sheet of paper and fold it a few times to make a paper boat. After playing with your paper boat, the paper sheet can be changed back to its original shape. You can see the same change when you hold your handkerchief into a scarf and tie it around your neck. If you untie the handkerchief, it comes back to its original shape. Take some wet clay and use your hands to make a particular shape. You may make a ball or an elongated shape like a rope or any other shape. If the shape you mold out of clay is not according to your liking, you can bring the clay back to its original shape. You can see the same change of size and shape if you take some dough made from wheat flour. You can roll it into a chapati. If you do not like the shape of the chapati, you can remake the ball of dough by pressing the chapati between your palms and fingers. Identifying changes as reversible and irreversible. By applying some kind of force, you change the size and shape of the object. But again, by applying the force, you could bring back the objects to their original size or shape. It also means that the changes that were brought about by you could be easily reversed. Such changes are called reversible changes. Take a sheet of paper and draw a boat with a pencil. Use a pair of scissors to cut out the boat from the sheet. What do you observe? The sheet of paper does not become the same, no matter what you do, to fit the cutting back into the sheet. What does this activity show? It shows that this change cannot be reversed. In this activity, a slightly different effort was applied. The things changed their shape or size, but they could not be brought back to their original shape or size. Such changes that take place in one direction and do not reverse are called irreversible changes. You are now in a position to differentiate between reversible and irreversible changes. Difference between reversible and irreversible changes. Reversible change, irreversible change. A change which can be reversed is called a reversible change. A change which cannot be reversed is called an irreversible change. A reversible change is a temporary change. An irreversible change is a permanent change. Physical and chemical changes. Physical change. The change in which no new substance is formed and the substance only undergoes a change in its shape, size, appearance or state is known as a physical change. Physical changes are usually reversible because by reversing the process, the original substances can be obtained. In all these changes, internally the substances remain the same before and after the change. Some of the examples of physical changes are tearing a paper. On tearing a paper, it changes its shape and size, but it remains a paper. As molecules of the paper remain the same, therefore no new substance is formed, and the change is temporary. Freezing of water. When water is condensed, it changes to ice. Internally, the molecules of water remain the same. Only its state changes when it becomes a solid from a liquid. It is a temporary change because on reversing the process, we can get water again from ice. Lighting a bulb. When you enter a room and switch on the light, the bulb is lighted. But when you switch off the light, the bulb is no longer lighted. Thus, the change is temporary because when we put off the switch, the bulb comes back to its original position. So the change is reversible. Chemical change. The change in which a new substance is formed, which have properties that are different from the original substance, is called a chemical change. In such chemical changes, new kind of molecules are formed from the combination of molecules of original substances. Such changes are usually irreversible and permanent because on altering the conditions, original substances cannot be recovered. The substances formed as a result of chemical changes have different properties than the original substances. Some examples of chemical changes are burning. Burning of paper, wood, or other fuels like petrol, diesel, kerosene, and so on are all chemical changes as new substances are formed. Such changes are permanent and irreversible, as after the change, original substances cannot be recovered. Rusting of iron. When iron comes in contact with air and moisture, it changes to a brown-colored substance known as rust. The process of forming rust on iron is known as rusting. Rusting eats up iron and it cannot be reversed. So it is a permanent change and an irreversible process. Cooking food. Cooking of different items like bread or roti, vegetables, pulses, rice and so on are all chemical changes in which new substances are formed with altogether new properties due to different combinations of the molecules of original substances. Once you boil a potato, you cannot revert it back to raw state. Growth. When we eat food, it is absorbed by our body and is used to nourish cells for growth. The substances that make up a cell are different from the substances present in our food. As new substances are formed in the cell due to intake of food, such changes are chemical changes. Conversion of milk to cheese. Cottage cheese or paneer is made from milk by adding lime juice to milk. This again is a chemical change because milk cannot be recovered from cottage cheese or paneer. As you can see, an entirely new substance with altogether new properties is formed. It is a chemical change. The molecules of the original substances undergo change to form molecules of new substances. As these changes are permanent because original substances cannot be recovered by altering the conditions, such changes are chemical changes. A chemical change occurs when there is a chemical reaction between the substances. In a chemical reaction, The initial substances react with each other to form new substances. The original substances that take part in the chemical reaction are called reactants. The new substances that are formed during and after the chemical reaction are known as products. Since new substances with different molecules are formed during chemical reaction, it is not possible to get the original substances back. Therefore, usually chemical changes are permanent and irreversible. A chemical reaction has taken place between the reactants, which are washing soda and lemon juice. As a result of the chemical reaction, carbon dioxide gas is evolved. The chemical change cannot be reversed to get back the reactants from the products. The chemical reaction can be written as washing soda plus water plus lemon juice gives carbon dioxide plus other products. When substances are mixed, it can result in a physical or chemical change. The kind of change depends on the substances that are mixed and on the conditions. Mix iron and sulfur. No chemical change occurs. But on heating the mixture, it glows after some time and a black substance is formed. The black substance is iron sulfide, which is a different compound with entirely different properties from those of iron and sulfur. Heating a mixture of iron and sulfur results in a chemical change. Activity: take a teaspoonful of washing soda in a bottle with a narrow top. Add a little water, about 100 ml, in it and shake it so that soda dissolves in it completely. Add a little lemon juice to it and you will observe bubbles being formed in the solution. A gas is evolved as a result of chemical reaction. Now, bring a lighted matchstick to the mouth of the bottle. You will find that it gets extinguished. It shows that carbon dioxide gas is formed during this reaction. As carbon dioxide does not support combustion, the matchstick gets extinguished. Difference between physical and chemical changes. Physical change, chemical change. Most physical changes are temporary and can be reversed on altering the conditions. Chemical changes are permanent and usually they cannot be reversed even on altering the conditions. No new substances are formed. The molecules of the substances remain the same before and after the change. New substances with different properties are formed. The molecules of the substances undergo a change to form molecules of new substances.